trust Ferguson Roof Systems to replace your roof, we go the extra mile to protect your home and property. On every job, we deploy durable netting to protect your home's exterior and landscaping. It's just one more reason why you should call Ferguson Roof Systems today.
All right, we are up and running. Hey everyone, Meteorologist Tuttle with you. It is about 10 minutes till 2 o'clock on a Sunday afternoon. We're here to talk about the severe weather event that's going to unfold coming up here in just a few hours across the Texas Panhandle and into southwest Oklahoma, and then expanding and elsewhere across the body of the state during the evening and overnight hours. So thanks for joining me. Make sure you like and share this video. Tell your friends and family about AT's weather. And share the video right now. As we're watching it, just hit the old quickly button so your friends can see what's going on. Because in case they, might want to be weather aware, this is probably one of those deals they're going to need to pay attention. We do have some big, strong winds coming. It's probably going to do some significant damage across areas of the state here for tonight, outside of the risk of tornadoes. But we're also going to talk about the tornado threat as well. We'll see if that's increased. We'll see the best areas for that to occur, all that stuff and more. You guys on YouTube, as always, thanks for checking in and leaving your comments. Jody be around here for a little while before she heads on off to a real estate appointment, so she might chime in with you for a little bit. You guys feel free to say what you got to say, and make sure you check in. Let me know where you're coming in from across the state, so I can know. You guys out there on Twitter, also thanks again for you guys watching as well. I know that platform's a little bit more streamlined than it is on Facebook and YouTube right now, but we'll get there. On Facebook itself, you guys can always opt in to get a live notification from me through your direct message system. So you just opt in, click that link I just posted. That way you don't miss a broadcast. And yeah, I know some of you have been sending me some stars, or at least trying to this week. Facebook is broken. I don't know, it doesn't work anymore. I'm sure they'll fix it at some point. That's the one frustrating thing about that platform, is there is no 8-100 number to call, right? Or even not even email. And I'm one of their top content creators, and I ain't got nobody. Anybody I did have in the past, they just ignore you when you email them, so doesn't do any good. Eventually get it fixed. Out there currently, though, setting the stage right now, cloudy skies. So, we had some cooler weather hit us. Cooler is that's a silly term. We had some cold weather slam us. How about that? For Thursday, Friday, and lingering into Saturday. Today, temperatures are finally starting to rebound a little bit. We're at 57 degrees now here in my backyard on my Tempest weather station, with the wind out of the south starting to pick up a little bit. But those clouds are hanging tough. You're going to see a little bit of break in the cloudiness, though, and things will start to change as the atmosphere becomes a little bit more unstable. It'll start out west first. So that's where we're going to start today's broadcast here as far as the areas to watch. And so what we're seeing out in the Panhandle, of course, is a lot of clear skies. This is a visible satellite picture. And you can see this little Q right here, towering Q. This is very meager moisture being developed by too much energy aloft, too much wind, too much shear. And so that's going to help to get things fired up here in a few hours across the rest of the Texas Panhandle. Now out here in Texas, you can see bits and pieces of breakage in the cloud cover, and that is working its way here into western Oklahoma and southwest Oklahoma. So we'll see a few of those breaks move through, but otherwise still mostly cloudy across the area. And the dew point values are starting to move from the south to the north. So if I show that to you here on this map, remember the magic number for tornadoes in Oklahoma is right around 60. So you want a dew point value of 60 or higher for a more likelihood of a tornado. Once they get into the 50s, it's very hard to do. But you can see the deep moisture is down here across central and southern Texas, where they've got some mid to even upper 60s at times in this little pocket that's moving northward, heading through Dallas-Fort Worth now, northeast Texas, and then out here into the Abilene area along I-20. So here's the difference. The models are still struggling to get the accurate position of this. They think it's more up in this region. So it's off by about an hour. It's a little aggressive by an hour. But the point is that these low 60 dew points will eventually work their way into this region by the evening hours, and then during the early evening out here across Oklahoma City and points southward. So it's just coming in at the very last minute. And we talked about this over the last couple days. If it had come in just a few hours earlier and we heated up a little bit more, boy, would we have a really bad outcome. We're still going to have a bad outcome, but I mean, it would have been, going off the data, I mean, it's one of those catastrophic, outbreak of violent tornado outcomes. We still might have a few violent tornadoes in this mess, but I mean, in that situation, we could have had dozens, and that's, it was a bad looking situation, but thank goodness that Arctic air slid in here and changed things up a little bit for us. All right, so here is a look at the red area. This is a moderate risk of severe weather from the Storm Prediction Center, outlined by enhanced in yellow. So pretty much anywhere in the yellow area, you're going to see some severe storms today. Doesn't quite go down to Dallas. You guys got like a general green area just for getting some random thunderstorms in your locale. If we look at the tornado threat specifically, the hatched area shows up here in southwest Oklahoma, right coming into the Oklahoma City Metro, westbound on I-40, and then kind of getting in toward the Childress area, covers Lawton and also Altus, and just on the north side of Wichita Falls. So that is the favored zone for seeing not only a significant tornado, but possibly even a violent tornado. And I'll show you the numbers on here in a second. But elsewhere in the brown, it's pretty much anywhere here is fair game for either a weak tornado, probably more along the lines of what we call a QLCS, which is develops along a squall line, versus more of a supercell embedded type tornado. That's probably more likely in this area. So two types of physics involved in developing tornadoes in those cases. One's a much stronger one that can lead to violent ones, and one's a weaker one that just leads to nuisance ones. If you're going to have one, I prefer the nuisance, right? Oh, let me go back to that other map also. That was just the tornado threat. I want to show you the wind threat with this. This is probably even a bigger story than the few tornadoes that we'll see today and tonight, but that is going to be the widespread damaging wind. So here in purple, this is the area where the up to around 60%. So it only, and with the hatched area of significance, so it really doesn't get any higher than this. Bottom line is, in this region, we're going to have wind speeds in excess of probably 80 miles per hour. Some of the data could indicate winds up around 100 to 110 miles per hour. Now, that's the same damage as a tornado, just so you know, and it's pretty much a decent tornado too. We're talking EF1 to possibly EF2. So again, that is some significant wind that's going to occur. Now, it won't be everyone in this purple area, but it's going to be quite a few of us that's going to see those winds gusting well in excess of 60. 60 is an easy call. Whether or not we get the 80 to 90, 100, that should be, knock on wood, more sporadic in nature, but enough to where it'll probably be a mess to clean up. And that does extend up into Missouri. So even though the storms themselves will weaken once they get here into eastern Oklahoma, the wind associated with it, because the atmosphere is what's producing the wind, not necessarily the storms, and that momentum is transferring down through the downdraft of the thunderstorm. That is what the severe weather is coming from in the form of damaging winds. Okay, so I could read you all the verbiage from the Storm Prediction Center, but the bottom line is kind of what I just said, which is a few tornadoes, some significant, and also some pretty decent damaging wind. If you look at a close-up view from the National Weather Service, they highlight this area here in red for you on the moderate. Hail size isn't really that big with this event. We're looking at around golf ball size, so that's not too bad. But again, there's those winds over 80, and the tornado threat went from low, looking at the data yesterday, to medium today, as it looks like those low 60 dew points will just work their way in time into southwest Oklahoma with residual peak heating before the cap builds in and they get a chance to be surface based. So the initial start that we'll look for tornadoes this afternoon, around after, say, 6 o'clock, will be down here across southwest Oklahoma into the southeastern Texas panhandle. But again, in the green area, there still is fair game, and things eastward kind of calm down a bit. Here's a look at the timing of severe weather from 5 to 9 o'clock this evening and afternoon, out across this area in light blue. Here in Oklahoma City, approaching by the 9 o'clock hour, and the rest of the I-35 corridor, and then moving off to the east. Winds behind the thunderstorm line, not with the thunderstorm line, but behind it, will be widespread wind gusts around 50 to 55 miles per hour. So there might be a little bit of extended power outages or damage just because of just the broad general wind that will transfer down. Will be extremely windy, and that is, again, outside of the actual thunderstorms themselves. Eastern Oklahoma, let's take a look at you guys. You're in a moderate risk that extends on up toward the Tulsa area. Notice the Weather Service wording here. A few tornadoes possible, could be strong. Then down in the southern and southeastern, the risk decreases, but your winds are still here. So 60 to 70 mile per hour winds anywhere in this area. Not expected to be too crazy down here in far southeast Oklahoma, maybe a gust up to 60. Otherwise, the strongest winds to the north. And the timing for you out here in the northern and western parts is between I-35 and, say, Tulsa. That happens between 9 and 11 o'clock. And then you got the rest of eastern Oklahoma as you head to about the midnight hour. As far as the winds are for you guys, also wind advisory in effect, as you'll have wind gusts up to around 50 plus miles per hour at times So, of course, that means loose objects. So, batten down the hatches. You got plenty of time this afternoon to go out there and tie up your loose things you don't want flying around. If you got a trampoline, I don't know what to tell you. It'll be in somebody else's yard, and it won't be in yours. Let's take a look at the tornado threat here on the analogs. In other words, we take a similar situation and what comes out of it. And it likes to put a little decent bullseye right here across the western half of the state for tornado potential, and also for the wind. It likes that as well. This hasn't really impressed me that much looking at past storms and trying to compare it to this one. The output, it's not as favorable with it. It's just interesting to look at. When we do look at the storm system itself, though, in the upper levels of the atmosphere, here's what it looks like. See all this bright color? This is all major lift. In other words, this is a lot of what we call vorticity or spin in the atmosphere. And the axis that it comes out is like this. So we call that a negative tilted trough axis. So when they come out negative tilted, it really enhances the wind field within the storm, within the jet stream, and that really enhances the severity of the thunderstorms themselves. So that's usually something you don't want to see. It's small, compact, it's right on the track, and honestly, you don't get a system like this that often. I mean, we're talking every 5 or 10 years usually. And when they do, they're not pretty, all right, with the outcome. Here's a look at the upper levels of the atmosphere, 300 millibars. We're going to do a check to make sure we can check off all the ingredients needed for severe storms. First, yes, we have the brute forcing with the upper level energy coming in. But we also need the wind field aloft to work in our favor as well if we want severe storms. So the winds come up like this, and they come out like this. So you have this split flow in between with these jet areas up around. Was at probably 115, 120, 25 knots in this area. So some good strong winds aloft in the jet stream way up top. And so that's one of the ingredients that we need to look at. Down a level below that is the 500 millibar level, and you look for speed maxes that come in. Well, look what we have here. There's 136 knot speed max. Let's just say if you were flying on a plane from west to east and you flew through this zone right here, oh my goodness, you'd be in Oklahoma City in like 5 minutes. I mean, the plane would not have to use any fuel at all. It would be zipping. But yeah, that's just an example of how fast this river of air is. And the problem is some of this air can transfer down, which is why you're seeing more stronger wording in the damaging wind department of up to 110 miles per hour, because some of the SES could, in theory, work its way down to the surface after you, of course, subtract for friction and distance and all that kind of stuff. But the timing on this to help the storms get a real boost is between 6 and 9 o'clock as they're moving out of western Oklahoma and into central Oklahoma. So the timing is right on the money to provide an extra kick to the atmosphere. And then one layer down, we go to 850 millibars. This is where you have the low-level jet kick in. I'll back it up to the 6 o'clock hour. That was the 9 o'clock hour. So we go from 6. Watch how the wind speeds, by the way, are significant enough, 60 knots. We go from that to, survey says, 80 knots. I mean, we're already talking near 100 mile per hour winds already, so a couple thousand feet off the ground. So we've got more wind than we know what to do with. And again, it doesn't take much to get some of that wind to come down the surface. And when you have those type of winds that crisscross each other, you know, this direction, then this direction, then this direction, that sets up the stage for rotating thunderstorms. And those are the kind that produce the tornadoes. So here's a look at the vertical velocity, 700 millibars. The brighter colors indicates the kicker, so we need to get storms to fire up. And by 6 o'clock, it's right here across the eastern Texas panhandle. As we head into the 9 o'clock hour, it does shift closer to the I-35 corridor. This is plenty of brute forcing to get those storms to develop, cap or no cap. But again, the key is, can they get rooted in the boundary layer? If they do, it's off to the races when it comes to tornadoes. Okay, so let's take a look here at the dew point values. This has always been the question over the last few days is, will we get the moisture in here in time? And the answer is barely. So this is the newest model. This is our high resolution short-term models. Let's go to 1 o'clock, 2 o'clock, 3 o'clock, 4. See the 60s? 5 o'clock, 6 o'clock. Magic. So there we go. They're coming into the far northern counties of the state. They're barely making it in time because in theory, remember, we're already going to have storms out in this region right here. So this moisture has to surge and feed into these storms to get them to be rooted and to get produce some tornadoes. So this is kind of the last ditch energy, or let's see, ingredients, put it that way, that wasn't there before, that is finally now showing up now. Of course, it's late to the party, but you know, if you're a thunderstorm and you want to produce a tornado, it's better late than never. Obviously, we don't want that outcome. We were rooting for the 50s to stay entrenched. In the earlier days, it looked like that might happen, and here in the last few minutes, it looks like we're finally going to get some low-level moisture in here just in time to help increase that threat down here in southwest Oklahoma. As we go to 7 o'clock, and 8 o'clock, you see how it surges northward to I-40 corridor, west to east. So any thunderstorm in here that is still rooted through 8 o'clock is going to have this extra enhancement of instability to deal with from the surface. That does mean, again, a tornado threat continuing. And there's 9 o'clock going through Oklahoma City Metro. We still peak into the low 60s, it looks like. But it's a fast mover. So by 10 o'clock, the threat's east of us. And we get this nice, dry, westerly wind that comes in, like I said, over 50 miles an hour in the wind gust. By 11 o'clock, the dew points have reached Tulsa, back to the south. So again, enhancement for some wind and just for stronger thunderstorms. But in theory, those storms should be weakening gradually with time as the cap builds in and some of the things that occur. Now let's take a look here at temperatures. So that was another thing. When we get out of the 50s today, well, 2 o'clock, 3 o'clock, 4, 5. You see still lots of 50s on this map. This close to 60, but it's just not a lot of instability, and that has been the saving grace. Again, if we hadn't had that Arctic air mass come in here and jack this atmosphere up, the first below the next 500, 1,000, 2,000 feet, it'd have been a different story. So thank goodness. Let's go 6 o'clock. We do get the 70s nosing in here, so the theta E axis coming in across Childress. So favorite area for initiation for potentially tornadic thunderstorm in that locale. There's 7 o'clock and 8. So still we stay in the low to mid 60s along the Red River and here in Oklahoma City. So thank goodness we don't ever get any warmer than this. That would have just added more fuel to the fire. But we're going to show you what that looks like, though. We'll take a look at let's just go with the CAPE, in other words, the instability available, along with the shear in the environment, in other words, how much spin is out there, and we overlay those into the Energy Helicity Index to where we can see the best potential for tornadic development. And right now, it's loving the eastern and southeastern Texas Panhandle out here in the southwest Oklahoma. And then as we go to the next hour, this is 7 o'clock hour. The colors get a little brighter. Numbers get a little higher, again, which favors this zone down along the Red River in southwest Oklahoma. By 8 o'clock, you can see these numbers increase and a little bit to the north along I-40, running west out of Canadian County, kind of barely getting in Oklahoma City Metro. They're mostly to the south. And then as we go into the 9 o'clock hour, we do have some of those lighter values up here, but they're not nearly what they were before. So the take home here is that the best area based off the instability for tornadoes is going to kind of be in this little quadrant here. Doesn't mean we can't have them outside of it, but as far as the more stronger into maybe the more violent time, that would be more favored in this zone based off the data. And we can back that up and take a look at what the environments look like in a forecast sounding, for example. So this is what we look at. In this particular case, like I mentioned earlier, we did have a little bit of a cap that's still left over, which might try to keep some surface-based storms from happening. And if they can stay more elevated as a result, again, that's a big saving grace for tornadic potential. However, we can look at some of these numbers. We can look at the storm relative helicity values in this little chart here. And we can look at the lifting condensation level values at the mean level. We can look at CAPE values, this kind of deal. So I'm going to show you the reason why. And we look at the hodograph here, which is a nice curve to it. So this nice curve is very suited for tornadic thunderstorms. And finally, we can look at historically, when you base off these numbers, put them in a magic pot here, what do we usually get out of it? Potential for an EF3, maybe even EF4 tornado. So like I said, that's above the significant level. Significance EF2. Once you get toward the violent level, you're up around EF4, EF5. So those are very rare. We rarely see them. It's the rare of all tornadoes, but it can happen. We do have environments where you have excessive amounts of shear and instability. Again, our instability, unfortunately or fortunately, how you want to look at it, is lacking across most of the state. There's a little section down there southwest. So let's take a look at what this means when we look back at all tornado events with time. And I'll say all of them, but the majority of them, like just over a good data set. So for example, this data set goes back to 2000. So there you go. So it's the 10-year data set. It's 2000, 2011, this researcher put together. So the red line here is the Energy Helicity Index value of 2. All right, so we'll look to see where we rely on that. But it looks at the most unstable CAPE value, which is on the scale at the bottom, which is 1,000 here up to 5,000. And we look at the low-level helicity values, storm relative helicity from 1 up to 0 to 1 kilometers from the surface up. So we look at these two tracks. So we're going to find out where we lie in this track, and all of these are tornado events that happen. All right, so in other words, this example, this one was a severe shear environment where they had the helicity or storm relative helicity values up around 850 meters squared per second square, but they only had a Cape value of around 500. So that's an outlier. If you have a bell curve, nice smooth, it's on the far end of a kind of freak status. So you have a freak status on this end, and then you have a freak status on this end, which is almost no shear at all, but a ton of Cape. So that's kind of how that works out. So now let's go take a look at what our atmosphere looks like. So we're going to go back to that forecast sign there in southwest Oklahoma, for example. So what we have here, most unstable Cape, 1680. Isn't that one of our graphic deals here? Let's see, most unstable Cape. All right, so let's go to 1680. Here's 1500. So we're looking right around this area here of the chart. We're going to go up this chart here. So now let's see where our shear is. And by the way, just so you guys know, you guys are now all becoming meteorologists right here as we speak, because you're looking at the same thing I do, so you can forecast the outcome. All right, so we're going to go to, we say shear from the surface to 1 kilometer. Check notes, 478. Let's go back to our chart. All right, 478 is right around here. So there we go. We got 1,700 Cape and almost 500 shear. That puts us right here in the middle. In the middle, surrounded by all this other stuff. In other words, this, to get an EF2 to EF5 intensity tornado, is smack dab in the middle of the data set, right in the bell curve. That's not good news. Again, this is around southwest Oklahoma where these storms will be developing. We can look at another data set. This goes back a long, long term, from 1972 to 1999. Looking about tornado storms versus non-tornadic storms. So we can look at the lifting condensation level at the mixed layer, and we can look at also the low level shear at a different value. So let's go and do that. We'll do it in meters per second. So 0 to 1 kilometer shear, meters per second, we're looking at 36. The LCLs, we're looking at 960. Okay, let's go back to our chart. So 960 puts it right around there, and 36 LCLs put it right up here, an outlier. In other words, this is such an extreme event, and this long database doesn't even show up. But what you can see, we are well north of this black line, which indicates tornado or non-tornado. So in other words, it's not even a question as to whether or not these storms are capable of producing a tornado. The environment, again, the environments we're looking at for tornadoes is there in the data set. So there you go. So there's a look at how you guys can forecast just like me, and you can figure out what these storms will be capable of, and unfortunately, it's not going to be good. All right, so let's get back to, let's just go into the data set on how things look going forward with time and how the storm structure should evolve. So thanks for, again, hanging with me. You guys are learning a lot here as we go through time, and that way you can see how the atmosphere really works. Okay, so let's go on down to the 4 o'clock hour and 5 o'clock. There you go. You can see these thunderstorms developing. They're broken up in nature, meaning these are supercell in nature. So in other words, it's not a squall line yet, which is a long blended line, which helps to reduce the tornado threat with time usually, and depending on some other things. Let's see. Let's go to 6 o'clock. All right, so 6 o'clock still kind of broken up. They do have a helicity track, which is this little shaded area for this supercell going across the I-40 area, and a couple of these north. Not unheard of. Usually it can mean damaging wind, it can mean hail, or sometimes it can mean a tornado if they have other ingredients there. Now, in this particular case, this seems to be a long-lived helicity track. Started here, and it has moved all the way here with the storm. In other words, that storm, once it gets healthy, now this data indicates that means it's probably, if it isn't rooted, it is very healthy, elevated storm that has no intention of weakening anytime soon and leaving a potential destruction along its wake. Now, the placement isn't set in stone. In other words, this isn't going to be exact. It'll be close. It'll be in the vicinity, but the models aren't that good. Down here in Southwest, they're struggling with the cap. They're thinking down here, you know what, that cap may hold surface development, and we may be okay south and east of Childress. It looks like it does finally build here at 8 o'clock, a couple of thunderstorms here on the south end, and that stretches on up to the north. Let's go on to 9 o'clock as they start to approach the metro. So you can see there has been some helicity tracks within these that disappear. But notice how the line has congealed to developing to more of a squall line. Now, even in the signature of this, these little bullseyes, this is the model's attempt to tell you there's still probably some embedded supercells within the line. So you still have a tornado threat going up through the 9 o'clock and 10 o'clock hour. That does include Oklahoma City, but again, things are also starting to weaken a little bit once we get to this time frame of 10 o'clock onward. But you can still see residual helicity tracks that did occur, which means we'll still have rotation within those storms. And as we go on into the 11 o'clock hour, these storms getting thinner in appearance. In other words, they're not nearly as thick, they're not as strong. You don't see nearly as many colors, in the purple category. You have a few of those cells up here to the north. After that, you go to the midnight hours. It goes through the Tulsa, east of there, and it really weakens, and now it just falls apart. 1 o'clock in the morning. Now, just because the storm line falls apart does not mean the wind will stop, because we still have a lot of wind that can transfer down as these storms decay, and then you can end up with like a shower basically, and with the wind gust with it of 60-70 miles per hour, which is crazy because normally those two are not co-linked like that. But that's just an example of how things may progress with the data tonight. We do look at the wind field behind the storm and associated with the storm line itself. Let's take a look at that. So, of course, it's going to be windy anyway as this storm system approaches here later on today and in this evening. But there's the panhandle wind, and you can see this is behind the dry line, and there are winds gusting here between 60 and 70 miles per hour, and that's not even a severe thunderstorm. These are indicative right here of little pockets of severe thunderstorm winds that are in the updrafts and downdrafts, and they're up around 70 miles per hour, standard stuff in the early stages. Let's go on into the 8 o'clock hour. Same idea, 9 o'clock hours, it moves into central Oklahoma. We've got some wind gusts here up around close to 80 miles per hour in the data. And remember, the forecast says not only could be 80, but it could be higher than that. It could be 90, 100, maybe 110. It's kind of speculative because of some of the things that are kind of trying to prevent this from becoming a serious, more widespread event. All right, but there's enough uncertainty where you got to put it in the wording. So there's some 70s here on the wind speeds going through Oklahoma City, 75. So that's pretty much close to 80. That's to see that on the model output. That's pretty impressive. So we'll be getting some damaging winds that do rotate through central Oklahoma and the I-35 corridor between the 9 and 10 o'clock hour. Then those do move to the Tulsa region. And you guys are also in that zone, but you see how they start to weaken some all over this line. So there's that general weakening trend, but there's still little pockets, of yellow here, which does indicate there's a 60 where it could surprise you. And then look what happens here along the line of the dry line itself that's moving through as these storms fire off to the east. That could easily contain winds up around 50 miles per hour. Now it's starting to kind of get weakened once it gets east of I-35 again. There's still some 40s in here. But kind of goes to show you why there's a wind advisory overnight, because there's still residual wind to go once the line moves through. So you're still going to hear things blow around. We did take a look at the CAM models to try to figure out, where's the best helicity tracks, or, the best spin in these storms that could produce a tornado. What you want to watch for here is the bullseye. So you see where that bullseye is? So I stop it right here. It's pretty much from Canadian County, southwest along I-40, and then back down here to northwest of Lawton, in this little sweet spot here in southwest and west central Oklahoma. So for tornado potential, that kind of highlights what we talked about before. It seems to be a favored area. As we go with time, watch what happens. All right, see how those all kind of disappear? So the best spot that the models like is in that little quadrant of west central and southwest Oklahoma, for tornado genesis. Doesn't mean they can't happen in other areas. The atmosphere is so not nearly the same. It's very weak. A lot of other issues going on that prevent that, but definitely that is the most favored area as kind of a gimme, if you want to put it that way. All right, if we look at the newest model that we have, that's kind of the new go-to that all the other models will be replaced by. It likes the same idea, kind of the broken supercells in the panhandle area, moving into western Oklahoma by the 6 to 7 o'clock hour. And it does have these little shadings here of helicity tracks with them out here to the west. And then there's that squall line taking shape. At the 9 o'clock hour and 10 o'clock hours, it rolls through the greater Oklahoma City metro area and up north along I-35 to approaching Stillwater, Ponca City, and then back down east a lot and around Duncan, Velma, heading up toward I-35 there as well. Still has some residual helicity tracks with it, but they're kind of getting left in the dust, meaning the storm's moving really fast, and and outpacing anything that's significant. And then it kind of continues to thin out and weaken, as we mentioned before. So it's the same look on all the data. Nothing's changed in that regard. So in theory, the forecast really hasn't changed, other than the fact that we probably will end up seeing a significant tornado or two out here across southwest Oklahoma. Could it be violent? It sure looks like that could be the case. Nobody wants that, of course. And the other issue with that is those will be moving, those storms, hauling. And we're talking 50, 60 mile per hour moving storms. So they're not exactly chaseable storms for storm chasers. And when you issue a warning on them, they're going the Weather Service will draw a polygon that's really long. Hey, Penelope, she'll be back. Come here. Come here, baby. She'll be back. Yeah. You all right? Okay. Jody had to leave, and she's been wanting the whole time. Come here, baby. Come here. I know. Come here. Quit dancing. Oh. Okay. You okay now? Yeah. She'll be back. Sitting here with me. All right, this is Penelope. She's 6 months old, a little Yorkshire Terrier teacup, the newest addition to the family. And she wanted some airtime. She's going to keep wanting until she got it. All right, so anyway, the rainfall is out here in western Oklahoma up to about 1 inch. You can get some areas here, the models like up to around 1.5 inches. And that can happen when you get some really heavy supercell type storms and squall lines and all that kind of stuff. And then otherwise, the models kind of have a hit and miss elsewhere. Southern and southeast Oklahoma, if you noticed, you're getting a thin line of storms, but it's not nearly as heavy in this area. They'll be much weaker in that zone. And then temperature-wise, we're looking at the 70s return, or at least close to it in some areas of the state for Monday and Tuesday, and then a little cool down toward the latter part of the week, next week. And then we'll see what happens around like the 9th. I didn't look long-term, but in older data sets, we had more cold air coming. That was really going to cool things down. So we'll see what happens in that department. All right. Listen, if I put you down, you behave. Go bother your brother or your boyfriend or whatever you want to call him. All right, off she goes. Okay. Hey, man, live TV. What do you expect? Okay, so let me see. I think I covered everything. And if you were late to the party, you missed out. So we spent about, was it 20 minutes going through everything? So I'll give you a quick little rundown. And then we'll let you go. And then I do plan on being live tonight, probably starting, guess it's probably right around 6. So there'll be some tornadoes probably developing in the far eastern Texas Panhandle counties from probably just north of Childress. And then we'll see how far south they could build in the far southwestern and western Oklahoma. So during that hour, be on the watch for that. So the best favorite area for tornadoes today, they could be strong, significant, might even have a violent tornado in there. We looked at the data set to show historically where we look in that field. Doesn't look good, but again, that's the area we're in dealing with. Again, the colder temperatures today and the lack of that deep moisture has helped us out tremendously to prevent this from being a widespread tornado outbreak where you would have dozens of strong and violent tornadoes. Thank goodness, because this is like I said, a once every 5 or 10 year event that's coming through, and that cold air saved us. So that's what you need to know going into this deal. Now, does that mean we won't see tornadoes? No, it just means that we'll have a lot less than we would have. So we'll still get a few. We'll probably get a couple strong to violent ones, unfortunately. Those are the ones who do the most damage, but they're also the most rare. They'll be more likely territory for those will be in southwestern and west central Oklahoma. So if I were to, let's use this little map right here, because it's hard to visualize sometimes without town names, right? Let's zoom this in. All right. Now, this is a loose deal, so if it falls just outside of here, don't shoot the messenger. But let's go over here. All right. Now, again, I mentioned the eastern counties here of Texas, kind of a deal. So we're kind of looking like this being the sweet spot right here for a strong to violent tornado, in my opinion. So that covers Hollis, Altus, Hobart, Elk City, Hinton, and Anadarko, just north of Lawton, that kind of deal. they should weaken whatever is in this path as they come in to the Oklahoma City metro area. So we do have a tornado coming in this direction, for example. As it comes to this environment, in theory, it should weaken little by little as it gets here. So in other words, it could be, for example, and it's just making this as an example. This is an official forecast, but let's just say it's an EF4 tornado somewhere out here. All right. By the time it got to here, because it's moving so fast and it doesn't have a chance really to lift and it stays anchored to the ground, maybe over here by the time it gets to here, because it has to go through cycles, maybe it's down here to an EF2. This is just an example of how it can weaken with time. And there's a difference, obviously, between the strengths of an EF4 to EF2 tornado. Those EF2s, they are strong. In other words, they are significant, but they're survivable. And as long as you have adequate shelter, you'll still be okay. You don't want to be in a mobile home. You don't want to be anything, weakly built. But you'll still be okay in that case as long as you seek adequate shelter. And it's always in the middle part of your home, lowest floor, away from all outside walls and windows. Can be a staircase, can be a bathtub, that kind of deal. So if you guys are coming in from California, New York, some other place, and you're going, what in the world's going on here? Are we all doomed? I'm telling you what you can expect, and I'm telling you how to protect yourself. A lot of times we can tell the kids, if you've got like sporting events for the kids, you usually have helmets and pads and stuff. We tell them put that on. If you want to put the old school mattress on top of you in the bathtub, go for it. You do that too. The key is you just want to prevent any flying debris from hitting you is what the goal is. Should you have, a wall that gets penetrated or a window that gets shattered, a roof, corner that gets lifted, something like that. That's what you want to watch out for. But anyway, so that's kind of the favorite area. And then outside of that zone I showed you, a QLCS type tornado, which is kind of like a squall line, a weaker tornado could occur. If it does include Oklahoma City Metro, northwest Oklahoma, southern Oklahoma. As we go east of I-35, the odds of that diminish greatly. But you still have the strong straight line winds that can come down anytime during this event. That's from western Oklahoma to eastern Oklahoma. It doesn't matter. It doesn't discriminate. And some of those winds, especially here in the metro of Oklahoma City, for example, they could be up around 80 plus miles per hour. So yeah, we could have pockets of damaging wind that do as much damage as a small to strong tornado. So also keep that in mind. How you can tell the difference. All right. So let's say, and this will be frustrating for the surveyors. When it comes to the National Weather Service, by this, sometimes emergency management gets in there too, but when they're trying to assess whether or not a tornado hit a place and went through, the damage is different. So in a tornado damage, you have items, trees, fences, homes, roofs, whatever, all in a crisscross overlapping pattern. All right. So remember, think of it, it's a swirl that goes on. So they all kind of get swirled, and they're all in different directions. Okay. So that's how you can tell it's a tornado. If it's a straight line wind, everything goes in one direction. Everything's laid over from left to right, top to bottom, all facing, in this case, east. So that's how you know you have straight line winds. So what's going to muddle this a little bit is if you do get a tornado that comes over first, and then you get straight line winds that come over after, they have a tendency to take what the damage was and then disperse it further in more of a west to east fashion. So it could obscure some of the tornado cleanup after the while, or the what am I trying to say? Come on, brain. Surveying. Hey man, I swear, COVID brain is a thing. I mean, ever since COVID, my brain is just like just farts on me. I'm like, come on, man. It's just a word. You can know what it is. You've said it a billion times. Or it could just be age. So I'm gonna blame COVID though. All right, but anyway, so that's how that'll pan out. So for insurance claims, all that kind of stuff. All right, and then I'm trying to think what else. So big wind event. Otherwise, some good rain with this. Heavy rain at that. Briefly, some hail up to about golf balls. Most of it's probably less than that. Just not a big event environment for hail. Not enough instability, which is good. This is mostly shear driven. In the past, when you have too low of instability and your shear is too high, there is a theory that you could rip your updrafts apart. I don't know if that's true or not. We kind of joked and talked about it because sometimes we'd see setups that looked great and we're like, well, how come they didn't hold together? How come they didn't form? We're thinking, well, maybe they ripped the updrafts apart. So I haven't seen any studies that says that. I don't even know if you could see a study to do that, but if you have too much shear, it might be too much of a good thing, so to speak, because there are bell curves and outliers for a reason, and that's why things typically don't happen on either end of a bell curve. That's why most of it, again, bell curve in statistics on an event is kind of goes like this, up and down, where everything happens in the middle part, in the big hump, and very little happens on the outer skirts. Those are called outliers. An outlier meaning rare events that are freak events. And probably because there's some truth to too much shear, not enough cake kind of a deal. But statistics show us that we'll be kind of in that sweet spot of the combination of the two. So I do expect some strong to maybe violent tornadoes to develop out in that favored area, as long, again, this is what I can't stress, as long as the models are correct, and those lower to mid 60 dew points do make it to the Red River Valley in time before the atmosphere cools down too much, cap builds, and some other things happen to where you get more of a squall line appearance versus a chance for independent supercells that try to come out of the Texas Panhandle. It is, I'm telling you, we are like, it's like this. Making this happen is like missed it by this much kind of a deal is where we're at. So these are the tough ones, right? Because, yeah, they're just the tough ones. It's not an easy call one way or the other. You have to kind of ride the fence and say, well, if this happens, it's going to be worse. If it doesn't happen, phew, one of those deals. So that's kind of where we're at. Okay, so look, I've gone on long enough. Can't tell you anything more because there is no more to tell you. Josh is really late to the party because he asked about the timeline. So yeah, that's all right, man. But yeah, the timeline is Eastern Texas Panhandle beginning around 5 o'clock. And then Western Oklahoma beginning about 6. Those will move through pretty quickly. And so from 6 to 9, moving through the western half of the state. And then once we get from 9 to 10, it moves through the I-35 corridor. And then it's off to the races on the eastern half of the state, up through about midnight to 1 o'clock in the morning. And the storm strength decreases slowly with time once it gets to central Oklahoma. So once it gets kind of to the I-35 corridor and then points east from there, every hour after that, the storm should start to weaken little by little, which is helpful. But you're still going to have, pockets of wind and all that kind of stuff, and maybe a QLCS tornado. But anyway, so there you go. Like I said, I'll be broadcasting live, I expect, later on today. So make sure you guys tune in for that and tell your friends and family they can get the storm coverage of tornadoes. You've already had your 15 minutes. It's my time. Tornadoes and stuff without all the circus, hype and stuff you see on. We got to teach you about this whole whining thing. That is not accepted in this household. I'm going to go spank my child when this is over. But you guys enjoy the rest of your afternoon. Remember, if you got something you don't want blowing around in the wind out there, make sure you go bring it in the garage or strap it down or something. All right, you guys be good. We'll talk again. We'll see you a bit later. Take care.